Alright, so in this video, I'm going to be proving to you guys that 2 plus 2 is equal to 5. So, to do this proof, what I'm first going to do is start with a true statement, that 0 is equal to 0, which is obviously a true statement because any number is equal to itself. Now from here, what I'm going to do is rewrite 0 on my left-hand side as 20 minus 20, and rewrite the 0 on my right-hand side as 25 minus 25. So now I get 20 minus 20 is equal to 25 minus 25, which is again a true statement because 20 minus 20 is 0, and 25 minus 25 is also 0. Now from here, I'm going to rewrite 20 as 4 times 5. So now I get 4 times 5 minus 4 times 5 is equal to 25. I'm going to rewrite this as 5 times 5. So I get 4 times 5 minus 4 times 5 is equal to 5 times 5 minus 5 times 5. And now, if I have something in the form a times b minus a times b is equal to b times b minus b times b, which is this form, well, notice how we can simplify this by factoring out the greatest common factor. So for my left-hand side, we have a greatest common factor of either a or b because both of them are in both terms. So what I'm going to do is I'm going to rewrite this as a times b minus b. Basically, I factored out a. Now for my right-hand side, all we have is b because that's the only term for my right-hand side. So I'll just factor out b. So I get b times b minus b. So now in the case of this, for my left-hand side, I'm going to factor out 4. So I get 4 times 5 minus 5, which is equal to, for my right-hand side, I'm going to factor out 5. So I get 5 times 5 minus 5. So now I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. And what we can do over here is, if I have something in the form a times b minus b is equal to b times b minus b, we'll notice how we can just cancel these two out, meaning that a is equal to b. So in this case, I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. I can divide both sides by 5 minus 5. And these two cancel out, these two cancel out, and I'm left with 4 is equal to 5. Now, going back to our original equation, I said that I was going to prove that 2 plus 2 is equal to 5, right? Well, what is 4 equal to? 4 is equal to 2 plus 2. So I get 2 plus 2 is equal to 5. So I just proved that 2 plus 2 is equal to 5. And now I know what you're thinking. This is mathematically incorrect, right? How can 2 plus 2 equals 5 when 2 plus 2 is equal to 4? Well, look back here and try to figure out where I made an error. So the error is actually right here in this step where I divided both sides by 5 minus 5. So let me write this right here. I have 4 times 5 minus 5 is equal to 5 times 5 minus 5, right? Well, instead of just going on and dividing both sides by 5 minus 5, what is 5 minus 5? 5 minus 5 is equal to 0, right? So this is basically 4 times 0 is equal to 5 times 0. And then now, if I try to divide both sides by 0, well, 0 divided by 0, that is not equal to 1. 0 divided by 0, that's indeterminate. So we can't actually cancel these out, because if we cancel it out, we're implying that 0 divided by 0 is equal to 1, which is wrong. So that's actually where I made the mistake when I canceled out the 5 minus 5s. I wasn't allowed to do that because that's basically dividing 0 by 0, and that is against the laws of mathematics. So this means that 2 plus 2 is not equal to 5. So, yeah. Alright, so in this problem, I have 2 to the power of x minus 3 to the power of y is equal to 7. So I want to find the values of x and y. So for my solution, if I have something in the form 2 to the power of x minus 3 to the power of y is equal to 7, I'm going to rewrite 7 as 4 plus 3. So now I have 2 to the power of x minus 3 to the power of y is equal to 4 plus 3. And the reason I did this was because 4 is the same thing as 2 squared. So now I get 2 squared plus 3. And notice how I have something in the form 2 to the power of number minus 3 to the power of number is equal to 2 to the power of number, and I also have 3 to the power of 1. Now from here, I'm going to group the powers of 2 together and group the powers of 3 together. So I'm going to subtract 2 squared on both sides. So I get 2 to the power of x minus 2 squared minus 3 to the power of y is equal to 3. And then I'm going to add 3 to the power of y on both sides. So then these two cancel out, and I get 2 to the power of x minus 2 squared is equal to 3 to the power of y plus 3. Now, for my left-hand side, I'm going to factor out 2 squared. So, actually, instead, I should say I'm going to divide by 2 squared. So, 2 to the power of x divided by 2 squared is equal to, well, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So that's the same thing as 2 to the power of x minus 2. And then I have this minus 2 squared divided by 2 squared is 1. And now this is equal to, from on this side, I'm going to divide by 3. So I have 3 times 3 to the power of y divided by 3. 3 is the same thing as 3 to the power of 1. So I get 3 to the power of y minus 1. And then 3 divided by 3 is equal to 1. So I get plus 1. Now from here, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 squared times 2 to the power of x minus 2, this is equal to 2 to the power of 2 plus x minus 2, and these two, and 2 and negative 2 cancel out, so I just get 2 to the power of x. So 2 squared times 2 to the power of x minus 2 is 2 to the power of x, and I have 2 squared times negative 1, which is negative 2 squared, and this is equal to 3 to the power of y plus 3. So I'm just checking if we distributed, if we factored out right, and it looks like we did. So now going back here, let me rewrite this. I have 2 squared times 2 to the power of x minus 2 minus 1 is equal to 3 times 1 plus 3 to the power of y minus 1. And notice how 2 squared, that's equal to 4, is an even number, and 2 to the power of x minus 2, well, 2 to the power of any number is even, and an even number minus 1 is going to be odd. So we have an even number times an odd number is equal to 3 is an odd number, times 3 to the power of any number is an odd number, plus an odd number plus 1 is an even number. So you have an even number times an odd number is equal to an odd number times an even number. Now, what I'm going to do is I'm going to set the odd numbers equal to each other, and then the even numbers equal to each other. So this gives me two equations. I get 2 squared is equal to 1 plus 3 to the power of y minus 1. And I also have 2 to the power of x minus 2 minus 1 is equal to 3. So let's first start with this equation. this is going to equal 4 is equal to 1 plus 3 to the power of y minus 1. And this means that 3 is equal to 3 to the power of y minus 1, meaning y is equal to 2. So the value of y is 2. Now for 2 to the power of x minus 2 minus 1 equals 3, I'm going to first start by adding 1 on both sides. So I get 2 to the power of x minus 2 is equal to 4. And now 4 is the same thing as 2 squared, so I get 2 to the power of x minus 2 is equal to 2 squared. And this means that x minus 2 is equal to 2. And if I add 2 on both sides, these two cancel out, and I get x is equal to 2 plus 2, which is 4. So my solution is x equals 4, and y is equal to 2.